Hello and welcome. In this video I'm gonna show you how we can use the implicit differentiation for finding the derivative of a very interesting function. If y equals a square root of sine of x plus a square root of sine of x plus a square root of sine of x plus continue this pattern forever, find dy over dx. As you can see here, we face a very unusual function. For finding the derivative of this function, if we want to start directly from this equation, it seems to be impossible to find the derivative of this function directly. Because if we want to use the chain rule for finding the derivative of this function, this expression here is inside this radical. But again, here we have this inside this radical, and we have this inside this radical. And this goes forever. So we have to use the chain rule infinite times. So we have to find a better way for finding the derivative of this function. First, let me rewrite this function here again. The function is a square root of sine of x plus a square root of sine of x plus a square root of sine of x, and so on. Attention, this expression is y. A square root of sine of x plus a square root of sine of x plus a square root of sine of x forever is y. Keep this in your head, that what is y. Now let me erase this part. For a moment, suppose we don't have these two here. Look at this. What you have here? You have a square root of sine of x plus a square root of sine of x plus a square root of sine of x forever. We have this forever. It goes till infinity. Remember, or you look at here, when we have a square root of sine of x plus a square root of sine of x plus a square root of sine of x, it is y. And exactly we have same thing here. So this is y basically. Now maybe you got the idea of what we want to do. I had this here, a square root of sine of x plus this. But when we look at here, we notice that here again we have a y. Because y is this. And exactly we have same thing inside here. So we can suppose from this point to infinity as again y. Suppose this to be y, and so we have y equals a square root of sine of x plus y. Now look at this new relation. We have an implicit relation. And now we can use implicit differentiation for finding dy over dx. Not the usual differentiation method. We use implicit differentiation because we have an implicit relation here. But before differentiating this, if you raise both sides of this relation to the power of 2, we have y to the 2 equals sine of x plus y. Why I did this? Because differentiating of this is easier than this. Here we have this square root, which makes differentiating a bit hard. So we raise both sides of the relation to the power of 2, and then we start finding the derivative. We take derivative of both sides of the relation with respect to x. What is the derivative of y to the 2? 2y prime. We bring the power 2 to the in front, we subtract the power y1, 2y, and don't forget to multiply by y prime because, attention, Here we are doing implicit differentiation, and we take derivative with respect to x. So when we take derivative of the y, don't forget to multiply it by y prime. Derivative of sine of x is cosine x, and derivative of y is y prime. Move the y prime to the left, move this y prime to the left, then we have 2y y prime minus y prime equals cosine x. If we factor y prime, we have this, and finally if we divide both sides by 2y minus 1, y prime is cosine x over 2y minus 1. And if you want, instead of y prime here, we can write dy over dx. We know that y prime is basically dy over dx, derivative of the function y with respect to x. So for this function, derivative of this function is this, a cosine x over 2y minus 1. But attention, if you want, you can replace this y here with this expression. Don't forget, y is basically this. So if you want, you can write your final answer in this form as well. You can write it in this form: dy over dx equals cosine x over 2 square root of sine of x plus square root of sine of x plus square root of sine of x forever minus 1. But because this form is shorter, I prefer this for dy over dx. So don't forget, the important step in solving this question is noticing that this expression here is actually y itself, because y is a square root of sine of x plus a square root of sine of x and so on, and we have again y inside here. So we suppose that's y, and then we have an implicit relation, and then we use implicit differentiation for finding derivative. I hope you liked this video, and see you in the next videos.